The music you're hearing right now is actually a very complicated sound pattern. It's got multiple rhythmic patterns going on, multiple melodic patterns all interwoven, and yet, if you're like most people, you're feeling some kind of underlying periodic pulse. That's the beat. Informally, the beat is just what you tap your foot to. And it seems so simple to us. We don't have to be taught the beat. It seems to just emerge in our minds spontaneously. But cognitive science is showing us that the beat is anything but simple. People often talk about the beat being in the music, but we've discovered the beat is something that's in the mind. If we were able to look in your brain right now, we would see very strong activity in the auditory regions of your brain, the sound processing regions, and that's of course not surprising. But let's say that you are just sitting still. You're not tapping your feet, you have no intention of dancing or moving at all. Nevertheless, we would see very strong activity in areas of your brain that plan movements and that regulate movements. Why are those areas active when you're not moving? This is one of the puzzles, and we think increasingly that the motor system is being used as a resource for prediction of time, which means that we don't wait for the beat and then move. We anticipate the beat and move right on the beat. The simplest way to show that beat is fundamentally a kind of a prediction is to ask people to just tap along with a metronome. And their taps are very closely aligned in time with that metronome. Often they tap a little bit ahead of the actual ticks of the metronome, which really clearly shows that they're predicting, not reacting. If we're using our motor system to predict the timing of beats through simulation of movements, then it's very easy to turn that into real movement, and then suddenly you're bobbing to the beat. So beat seems to connect in interesting ways to very important things that our brains do. Movement, language, memory. Understanding how those work can teach us about how one modality's sound can help another modality, movement, in patients with motor disorders. It can teach us about how rhythms in one domain, like music, can affect processing in another domain, like language. It can teach us a lot about how different brain regions work together to produce the remarkable feat of human cognition.